Hi guys, welcome back to Super Math for You. This is Mr. Urrego, and today we're going to determine whether a table represents a linear function or an exponential function. Here we have three table values, and we have linear function and exponential function. The way that these tables are presented most of the times are this. Look at the x values. Increase by 1, plus 1, plus 1, plus 1. All right? Here on the second one, plus 1, plus 1, plus 1. So the increments are by 1. All right? You got to be aware of that. And the whole idea is to make it easier for us to identify if it's going to be linear or exponential. We look at the y-axis or the y values. All right? And depending on that, we're going to see how is the increment. So from the first value to the second value, I'm adding 5. If I'm going to have a linear function, okay, that means that this increment that I'm talking about is going to be my rate of change, which is my slope. If the rate of change is the same for every single step, which we can see is plus 5 in every single one of them, rate of change, the increment, is constant. Therefore, this is my slope. And this is a linear function. Now I have my slope. I need to find my y-intercept. Okay, my y-intercept is when the x equals 0. X equals 0, my y-intercept is 10. Having my slope and my y-intercept, I can write my equation. Y equals m, which is 5, x plus 10. And this is a linear function. Let's go for the second table. So the first thing we have to do is to check what's going on the y values. In my case, there's an increment of plus 5 here, but then there's a plus 10. My rate of change is not constant, so it's not linear. So now let's check if it's exponential. So to be exponential, there has to be something that is called common ratio. And my common ratio is going to be either my growth or my decay factor, which is the b value. So the way I do my common ratio is by taking this value and dividing by the previous one. Take this value divided by the previous one. As you can see, we're getting the same value. 40 divided by 20. I'm getting a ratio of 2 and it's constant right now. 80 divided by the previous one. As we can see, we got a 2 in all of them. And that's my growth factor. Okay, so that's my b value. Therefore, this is a exponential function. So to write an exponential function, I need two things. I need my growth factor. I need my a value. My a value is my initial value. The way we find out our a value is by writing my equation and replacing any of these points. We plug it in our equation. So let's replace the last one, 3, 80. Y is 80. A, I'm looking for it. B is the 2, which I just found. And the x is equals to 3. 80. A, 2 to the third power is 8. This is the same as having 8a divided by 8. And that means that my a value is 10. Plug it back in. Y equals a b to the x. Y equals 10 times my growth factor is 2 to the x power, and this is my exponential function. Like I said before, the 2 is my growth factor. If it's a number greater than 1, it's a growth factor. And this value is my initial value, which is the a. And we didn't have to do all this. Let me just show you something. Look at this. When the x is 0, the y is 10. That's my initial value, which basically is a y-intercept. Okay? Let's take the last one. Let's find what's happening in the y values. This is plus 5. This is plus 10. Right there, because it's different ratio, it's not linear. Let's check if it's going to be an exponential. We do the common ratio. Let's divide this by the 5. 10 divided by 5 is 2. 20 divided by 10 is 2. So far, so good. 30 divided by 20. Oh, no. This is 1.5 because this ratio is not the same. Therefore, this is not linear. So not linear, not linear, not exponential, neither one of them. And that's a very common question on the SAT and any of those states testing. Okay guys, if you learned something, please like the video. That's going to help improve our channel and it's going to get us into the algorithm for YouTube. Subscribe to the channel, hit the notifications bell, and check this video. I'll see you in the next one. Take care. Bye-bye.